Hi, it's Carly McAvoy. Today I'm talking about some very typical problems that you may find crop up in your algebra class. If you're one of my students, these are the 6 problems off the practice final. This video is going to take me a little longer than usual to get through because there are 6 word problems. So you might want to take a look at these problems, freeze the screen, and see if which one of these you're interested in watching. If you want to watch them all, let's get started. The first one says the length of a rectangle is 6 inches longer than it is wide. So if you have a rectangle, we have the width and we have the length, and 6 inches longer than the width would be W plus 6. If the area is 40 inches squared, what are the dimensions of the rectangle? Remember, an area is length times width, so we're interested in the width times the length here. And so if I set that up to start with, I have W times W plus 6 is 40 because that's the length and the width. I'm going to go ahead and distribute that W through there. That's going to give me W squared and 6W. And then we're going to subtract 40 from the right. Subtracting 40 from the right makes 0. Because we subtracted 40 on the right, we have to subtract 40 on the left, and we come down to this. Now, this is not a video on factoring. Please go watch one of my videos on factoring. If you're interested, leave me a message in the comments and I'll send you a link. But I have a lot of videos about factoring, but we're going to go ahead and break this down. We're going to get W plus 10 and W minus 4 because we wanted positive 6, and our last 2 numbers have to equal negative 40. And then we're going to solve this by setting each of these equal to 0. So W plus 10 equals 0 or W minus 4 equals 0. I can see I didn't actually cover that answer up earlier. That's fine. And so if I solve both of these, I get W is negative 10 or W is 4, and the width cannot be negative. So since the width can't be negative, it has to be 4. You can't use the negative 10. But then if the width is 4, then 4 plus 6 is going to give us 10. And you can check that very quickly to say, do the 2 dimensions that I found, are they 6 apart, which they are, and do they multiply to equal 40? And they do. Okay, that's type number 1. Number 2, the Golden Gate Bridge is 2,960 feet, 65 feet longer than the Brooklyn Bridge. Together, the bridges are 14,997 feet. How long is each bridge? The first thing we would want to do here is to declare our variables. In this case, we know that we can say that B is the length of the Brooklyn Bridge, and then we can say that B plus 2,965 is the length of the Golden Gate Bridge. And so, because we were told that in the problem, so now we know that the 2 bridges added together should be 14,997. So instead of the Brooklyn Bridge, we're going to replace that with B. And instead of the Golden Gate Bridge, we're going to replace it with B plus 2,965. And that's what that equation looks like. You have to include the Brooklyn Bridge as well as the Golden Gate. A very common mistake is for people just to do B plus 2,965 and forget about that Brooklyn. But the 2 bridges have to both be represented. Solving that, 2B plus B is 2B. Subtract this from both sides, and that leaves 12,032. And then we're going to divide both sides by 2 to find out that B is 6,116 feet. We said B was going to be the length of the Brooklyn Bridge, so I know that's the Brooklyn Bridge. And then I know that if I take the Brooklyn Bridge and add 2,965, I get the Golden Gate Bridge. And if the check for that would be, do my 2 bridges actually add up to the 14,997 feet that they said they were going to add up to? And they do. And they're also the difference is going to be what it says it should be, 2,965 on those. Okay, probably the hardest one is the hypotenuse. Find the hypotenuse. Another one that involves factoring. We have the shortest leg of a triangle is 2 inches shorter than the other leg. So we have some leg that's A, the other one is A minus 2, 2 inches shorter, and the hypotenuse is given as 10. This should say right triangle. I left that word out, and it makes a difference, right? So, because we can use the right triangle formula here, a squared plus b squared equals c squared. Instead of b squared, we're using a minus 2, and instead of c squared, we're using 10, but I can think my first side to the second power, my second side to the second power, and then 10 to the second power. And then I'm going to just go through and simplify that by taking a minus 2 to the second power. Remember, a minus 2 to the second power is a minus 2 times a minus 2. If you FOIL that out, you get a squared, and then your a to the, times negative 2 times a is how you get negative 4a, and negative 2 times negative 2 is 4. So common mistake is just to get a squared plus 4 there and forget that middle term, so be careful with that. Once you have that, we're going to add, just continue to simplify this. We're going to get a squared plus a squared is 2a squared. We have the minus 4a. And then what I did here was subtract 100 from both sides. That made the 100 go away on the right. And 4 minus 100 is negative 96. And now I'm ready to divide both sides by 2. Why would I do that? Because I can. 0 can be divided by anything without even changing it. 2, I can divide all these terms by 2 and just get much smaller numbers to deal with. Again, I don't have videos on factoring. This one isn't one of those, but we're going to factor that 48 into 8 and 6. 8 negatives, so we have 2 more negatives than positives, and then we're going to set each of these equal to 0 in order to solve. And we get a minus 8 is 0, or a plus 6 is 0. And again, we're always looking for the positive solution because we have a length of a side, and we can't have a negative length of a side. And so that gives us a equals 8 or negative 6, which means our solution that we're looking for is 8. The first leg here is 8, and the second leg is 8 minus 2, because we said it was going to be 2 inches shorter, or 6 inches. And the check for this looks like this. We have 8 squared plus 6 squared should equal 100 squared. That's 64 plus 36, which does equal, and that would be the check. I know I'm going fast. You can slow this video down. You can pause it. You can skip around, but I need to get through all of this. Okay, Mallory's Cafe charges $2.75 for an Americano and $2.25 for a drip coffee. If she sells 32 drinks in one morning and makes $78, how many of each did she sell? Like with any of these problems, there's more than one way to solve them. I'm solving them the way that makes sense to me and that I think that is the best way for you to solve them. But in order to solve this, I want to declare my two variables. I'm going to make A equal the number of Americanos sold and C equal the number of drip coffee sold. And then I know that altogether they sold 32, so A plus C is going to be 32. And then however many A they sold, they got $2.75 for each of those. However many of C they sold, they got $2.25 for each of those, for a total of $78. Now you have a choice here of how you're going to solve your system. You could rearrange the top equation, isolating one of those two variables, and then you would be using substitution. Or you could multiply the top equation by negative 2.25 so that your C's would drop out, or by negative 2.75 so that your A's would drop out for the elimination method. In this particular problem, I think with the decimals being what they are, it's easier to use the substitution, that is, rearrange that top equation. And so all I did here was subtract C from both sides, and I got 32 minus C. I got that A by itself. Now I'm going to go to that second equation, and I'm going to replace the A with what A is equal to. So where A is 32 minus C, that's what I'm putting in here. And then I'm going to go ahead and solve this equation by distributing the 2.75 times 32, and 2.7 times C. There's a negative in there. And then I'm going to simplify by combining the C's and also subtracting 88 from both sides. That's going to get rid of 88 over here and give us negative 10 on the other side. And now I can see that if I divide both sides, I should get 20. Again, we're looking for a positive solution here because we're saying how many of those did you sell? You could sell 0, but you can't sell negative numbers of coffee. So if you get a negative answer, you have to be thinking like that doesn't make sense for this particular problem. Okay, what does that mean? It means she sold 20 cups of drip coffee because we said C was going to be the drip coffee, and that's what we got. And then if you sold 32 altogether and 20 of those were drip, then you must have sold 12 Americanos. Here's the check for that. 12 plus 20 does equal 32. That's first step. Second thing is if I multiply 275 times the 12 Americanos and 225 times the cups of coffee, that should add up to 78. And you can do the math to check that, and it does work. I'm always showing you a check. You don't have to be on a test and go, wow, I hope I got that right. Moving on. Like, go back and check and see. Does your answer make sense? Okay, number 5. Two cars leave Olympia at exit 105 at the same time, one heading north on I-5 to Seattle and one going south on I-5 to Portland. The southbound car travels 12 miles per hour faster than the northbound. If they are 111 miles apart after 1.5 hours, how fast is each car traveling? Whenever you're talking about a traveling problem, you're talking about D equals RT, or distance equals rate times time. We know that they both travel for 1.5 hours because they leave at the same time and they're going in opposite directions. What that looks like, well, let's do this first. I want to declare my variables. R is going to be the rate of the northbound traveler, and the southbound guy is going, or girl is going 12 miles per hour faster, so R plus 12. So those are my two rates that I'm looking at. We know they both travel for 1.5 hours. So I always like to draw a picture when I'm thinking about these. If here's Olympia in the middle, one person's going north for 1.5 hours at some rate R, that's our northbound traveler, and the other person is going 1.5 hours at a rate of R plus 12. And then at some point they get 111 miles apart after 1.5 hours. So we know that the distance south plus the distance north, this person's distance plus this person's distance, they add up to 111. And so we just have to say, well, what was their distance? Remember, distance is rate times time. That's where we get 1.5 times R. That's our northbound distance is 1.5 R. Our southbound distance would be 1.5 hours at this rate, R plus 12. And those things add up to 111. So if you're going 50 miles an hour for 2 hours, it would not be hard for you to say, oh, I went 100 miles, 50 times 2. So that's all we're doing here is saying however time and whatever speed, multiply those together to know their distance. I went ahead and did 1.5 times R and 1.5 times 12. Now I'm going to add the R's together. That gives me 1.5 and 1.5 is 3R. I actually have 15, but it should be 1.5. Oh, heavens. Can't quite get that right. And then subtract 18 from both sides, and that's how we get 93. And now you're going to divide both sides by 3 to get 31. What is 31? 31 is the rate of the northbound traveler because it's R. So we have to then say the northbound traveler is going 31 miles per hour, and the southbound traveler is 31 plus 12, or 43 miles per hour. You might think that was super slow, but if you live in the area, I will just tell you they were doing that right as JBLM was letting out, and the traffic was crazy going north, and the southbound traffic was also slowed down. Okay, happens all the time up here. How do we check that? 1.5 times 43 plus 1.5 times 31. The first person who's going south here got 64.5 miles in, and the other person got 46.5 miles in, for a total of 111 miles. Okay, last one. In 2020, a community college had 2,340 students and found that they were recruiting 102 students a year. T is the year. Set up an equation describing this situation. What year would it be when they reach an enrollment in of 3,564? We're thinking about y equals mx plus b here. Our variables are t and n instead of x and y, but the same idea. M is the slope, which is the change over time, and b is the y-intercept, which is the starting point. In this scenario, the starting point is 2,340, and the changing over time is 102. They're adding 102 students per year. So for us, instead of y, we have enrollment, which is n, and then instead of x over here, we have t for time, and it's 102 people added every year with a starting point of 2,340. To find out when they would have 3,564, you're going to substitute the 3,564 in where n is, and then solve for t. And to do that, we would be subtracting 2,340 from both sides, and then divide both sides by 102, and we get t is 12. So 12 is not our answer. It's been 12 years since we started talking about this, which was 2020. So in order to get that year, it would take 12 years after 2020, which means it'd be 2032. And if you go down here to the check, 3,564, 12 years at adding 102 people, starting with 2,340, that would make sense. You might say, well, 12 was our answer. 12 can't be our answer because they said what year was it? And we know that we're looking for some year after 2020, and it happens to be 12 years later. So I was right. This is a 15-minute video. Apologize for the length of this one, and I'll see you next time. Have a great day.